Take everything with a little bit of a grain of salt here as we're still actively working. When the panel's complete, you're going to have these exact diagrams. They're going to be laminated. They're going to be mounted inside the enclosure. It's going to tell you information about how everything's wired. Okay. For these air handlers, all these panels are set up identically. They each have one of the new Optiflex OF1628 controllers, along with a single expander, an FIO expander. Their safety relays are down the side here. They are labeled. They're labeled on the side so you can see them so that you don't cover up the status light. But they're labeled over here with what each safety relay is. If you did want to shut down a unit or run a test and say, hey, does the logic work with the smoke detector? Come over here, I find a fire alarm system relay, I should say. That's safety relay number 2. I can pull the block and it'll kill the safety circuit, and the whole unit will shut down. Everything now, if you're familiar with the older installations of automated logic, most contractors are using regular AC transformers to power the power controllers. There's a significant savings of size, not so much cost. It's a little more expensive to use DC power supplies, which is what we have here. The real savings comes in the draw from the controller. Whereas for this controller and expander, you would need, is it a full 100 VA or is it like 90? Just this controller is 100 VA. You need a dedicated transformer for it. Whereas if we do it on DC, we can do this with 50 watts, and we can do this with 12 watts. So it's about a 30% difference in the size of the power supply that we have to put in. Power supplies and DC supplies are a little more expensive, but it's worthwhile in the long run. And actually, in addition to that, there's a little better noise, a little bit better noise handling on the lines when you're using DC. The controllers themselves, if you're familiar with the older line, they would have had pots and switches and whatnot next to the connections. All the same thing here, just underneath this cover. All of these upper level OF controllers are going to have handoff auto switches. So if you did want to manually trigger a relay, manually do something right from the controller, you can do so with these switches here, and they line up to the outputs that you see above it. If they're analog outputs, each output has a pot. You can literally dial in. If you want to say, I want this valve to go to whatever 8 volts is, I can use my little tweaker screwdriver and I can send it to 8 volts. A little bit easier to manage in relation to connection and setup. There's a service port right here on the front. If you did need to get into the controller and make a change to say its IP address, anything like that. That gets me to another major shift in how things are handled for automated logic. These are all networks devices. They have an IP address. There is a dedicated BAS network that is separate from the building's network. So you don't have to talk to an IT department to IP address this. You don't have to go through a firewall. These are all on a dedicated IP network that is just for building automation equipment. And you can come in, you can plug into this, and we have a DHCP server. So you basically plug your laptop in, get right into C, just like you were when you sit at your desk. Don't have to worry about anything in that regard. Do you guys have any questions about the hardware? What do you see? About the panels? Panel's a panel, right? All right. For the units, we talked about the 2 wheels. All the relays for this fans should be mounted outside the VFD, so you can see that. Yeah, you can get to it easy, right?
Yeah.
Well, don't worry. I don't think they're going to be able to get a lot of the ladders out of here, so you'll probably have a lot of ladders. Yeah, maybe even lifts, for all we know. But all the relays should be mounted within so that you can at least see them. Whether you can get to them is a different story. So you'll be able to see whether or not we're commanding things on, and then also what the status is of the safety. So if we look on, for example, on this exhaust fan VFD, the one on the left is our start-stop, and the one on the right is our safety relay. So both of them being on means good to go. UPS down here for the systems. The only thing that happens under emergency power for these air handlers, everything shuts down, except for one thing, which is modulation of the hot water valve to the hot water flow. So a lot of air handlers would simply use a shutdown to fire the valve wide open, and if there's hot water, run hot water through the coil to protect it, right? We're not doing that here. We're actually still under a safety condition. Even a freeze-set trip, we're still doing an active control of the valve, meaning that there's temperature sensors inside that we use for discharge, and if the air handler shuts down, that valve then controls just like the plenum, just like a room, to that temperature sensor, and keeps it at 70 degrees. So it keeps it from freezing. The two wheels that we talked about earlier, that's these obviously giant Thermotech. I don't have my special Thermotech key. That's this enclosure, and then the second enclosure is over here, which is open, so we can actually look inside of that one. So a small ADB VFD, a Distech controller, and that's what controls the wheels. There are 4-point temperature sensors on the Sensible wheel, and there are 4-point temperature sensors on the Total wheel, and 3-point enthalpy. So you have 3 points of monitoring of humidity on that wheel, no humidity monitoring on the Sensible wheel. And that's it. So they're still using transponders. But, same situation here. We have a RIB relay. We do have a physical point to enable. All it does is just enable the wheels or disables them, and we're doing that right from our controller.
So your set point is based off of that.
You got it. Based off of this connection here, which basically runs over to that switch in there and ties into the BAS. So that's how we're getting our integration. And if you want, offline, I can show you how to log into each one of these. It's pretty easy. They have their own web page.
Oh, okay.
It's not bad. I have to say, it's not a bad setup. So I think they're coming out. They have a controller that went bad in Air Handler 3. So Thermotech should be out here sometime in the near future.
Meaning next week or so.
It might not be a bad thing to talk to them and get some information about how their stuff works. Are there any questions now that we're standing in front of you? Are there any questions that you guys have about the air handlers? In fact, a memory just popped up about something that's going on here that I can talk about. The air handler was delivered with this, which is an airflow station. That basically is piped off of the fans. So it's pressure internal to the fans, measures how much air they're moving. That's not what the design was. We have an Ebtron airflow station in the discharge ductwork, the return ductwork. We have one in the exhaust ductwork and one in the OA. So that's belts and suspenders. So that's that thing sitting there, and I think we are using the ones for the exhaust. We're picking them up, and we are picking these up, but they're just monitoring. So you have a belt, okay, so belt and suspenders, both open up your pants, but the Ebtrons are the one we're actually controlling, right? Any other questions about the air handlers? All right. Well, deep vein thrombosis has been averted. All of our blood is now moving. If we want, is this the first time you guys have been in a building? No. So you're familiar with the layout of the penthouse and everything?
Where's the air handler sit?
Say again?
Sit.
Right there.
Next one.
I got a question about the air handler. Sorry.
Yeah. Fire away.
The end switches.
Yes.
If they're all linked in series, how does one drive determine if they turn them on or off?
So here's how it works. There is in the safety logic, we can go look at it. The drive ready to run is part of the safety logic.
Okay, so each one are linked.
No, I can try, but it's easier for me to show.
Right. Oh well, I don't know.
So here, so what we have are those safety relays that are here that tie in, and then the damper motors are actually driven. We do control them, but they're driven by a ready to run from the VFD.
Okay, so
so
you-
if you turn the VFD on, it closes a set of contacts, and then we power the motor and drive it open. So that's how each one individually knows. And if one VFD, right, it's set up so that if both VFDs go out on the exhaust, unit shuts down and the damper's closed. If one of them's running, unit can run. Same on the supply. One fan's running, unit can continue to run. But if both of them drop out, whole unit shuts down.
Okay, so electrically they're tied
Correct.
together.
You got it. So you see that the supply and the exhaust are tied together. That's how.
That's it.
All right.
Yeah.
Make sense?
Yes. Thank you.
Yeah, no problem. No, I'm very fanatical about my
Yeah.
safety wear.
I'm sitting well, yeah, and I like the fact that
It's not as important for air handler 6. That's why I asked Nolan if he had designed it that way. Because it's not a big deal if you have one air handler that's pressurized with a conductor. When you have multiple, it's very important to be able to throw it in the hand and have it start the same sequence that it does when we run the clock.
I agree.
Yeah.
Even though I'm more, I like running all that. I just want to.
No, what most of the time what we're doing is we're designing. Like if everything works great all the time, then it would be easy to do this stuff. But we're designing, the majority of our design and the legwork that goes into it is how to make sure that it's easy to work with if you have a problem. Right. And so that's what a lot of it is. So this is air handler 6. I will let, the control panel cord is over here. And I'll let Nolan talk about it because
Our guys obviously have some tidying up to do in here, but it'll be a similar deal. You'll have laminated panels over here that will lay out. Primary difference between this one and the panel that you saw over there is really just the position of the safety relays. There's a lot more safety relays in that panel. It's a little more economical to put them vertically along this side, but it's the same ordeal. I mean, it's the same type of controller, same type of expander, DC power supplies, network switch. You don't have the wheels on the side of the unit, so you don't have that extra network drop into here. This is just one network drop. They might have this might be the drive. There's an energy recovery coil. It's on the side of the unit. The pump skid for the energy recovery system is back by where we were sitting back there. The coil for that, is the coil down here on this floor, or is that upstairs? That's upstairs.
The unit is right
On
there.
the exhaust side, yeah.
Yeah, it should go right down there.
It's right down there. Yeah, I mean, not a whole lot different for this one.
What are the filters for the
Filters?
for the exhaust?
Oh man,
For
the exhaust.
Because you didn't show it in the graph.
They, let's see,
Are they individually insured?
wouldn't be here anyway. They're not, I believe on the graphic, they're shown if you're looking at the air handler. They're not shown if you're looking at the exhaust handler.
Right.
It'll be on the exhaust on the air handler graphic.
Well, it should be before the energy recovery.
Yeah, the coil, I believe, is going to be down here.
All right.
Totally separate, air systems. Yeah.
Right.
Yep. Yeah, as I said, very similar panel to what we have for all four other units, slightly different layout. Any questions about 6 particularly? No? Just want to see where it was?
where are the exhaust fans?
Is that
Well, where on the roof?
Oh, the exhaust fans are
Yeah.
they're in the roof wall up on 14.
Yeah,
Up on-
they
Yeah.
they're sort of
We
back
can go. We can go
That
up.
direction and up.
Yeah.
I'm just curious
Yeah.
how far it had to. If the supply and exhaust came back to the same place, or
Yeah.
if it was split.
That's the ER unit. Yeah. So this is the ERE unit right here. Yep. That's
This
Yeah. So gets drawn out of the building right here. Drawn out of the building right here, and you can see your pipes in the unit right there. That'll be your access to the building. Get inside to get in. And then you can see it penetrate the roof or the ceiling above us right there to
Up
go up
to the
and
fence.
I believe it continues going over and out to the exhaust.
It connects to the bottom of the fan.
Yep.
With those strobics up there, and then the strobics just take care of the rest.
Does the air handler take hatches? Is that probably
I don't know.
I happen to think so. For labs. I actually don't think the cadavers is mine. I think it's people that live in that work.
No controller for us specifically on this section. Everything that we needed over here, sensors or anything, came from the Air Handler 6 controller. And then the exhaust fans themselves have their own controller upstairs. So the exhaust fan controller is separate from the A6 controller.
You know what's cool about this? Like you can change the filters here instead of up on the roof. You'll plant them right next
Right.
to the fan. It's such a big deal. A lot of people don't understand that. You don't have to plug up.
The hardest part's going to be scheduling. Right. That's the hardest part of all.
And as mentioned, this is, I believe this right here to our left, to my left, is the pump skid for the energy recovery.
To do a high call system.
Yep. And that has its own. Where did they mount the controller for that? That does have its own. Maybe it doesn't. No, I actually think we're controlling that off of the Air Handler 6 controller as well.
Okay.
It's just pump, start, stop, and some temperature sensors basically that come over.
It doesn't even have VFDs, they just have starters.
Correct.
Yeah, so I mean, it's a very simple setup.
Yep.
Are we getting any context from the glycol system?
Not have a check.
All right. So it's 9:30. I think it might not be a bad idea to take a break, and then we can talk about chillers and cooling towers and everything like that. But